Hub and spoke model. Now what exactly we want to do in this? I will have one virtual network which I'll call it as hub, and this virtual network will do peering with multiple other virtual networks. These are all called as spokes. Hub, spoke, if it does peering with all of these. Now, if suppose there is a connection between on-premise and hub virtual network. Imagine if there is a connection. We have set up site-to-site connection, or it need not even be site-to-site. It can be point-to-site, or it can be VNet to VNet. VNet to VNet, point to site, or site to site, any form of connection. If I'm able to reach to the hub, we have just now seen using transit, we will also be able to reach to the spoke. But right now what you should know is a communication between one spoke to the other spoke is not allowed. Like in our example, if I take demo east VNet is, let us say, the hub, and I have enabled transit with west. Now from here, because of the transit, via this gateway, I am able to reach to the virtual machine which is here. Likewise, if I create one more VNet, via this gateway, I will be able to reach to the VM over here also. But what if the VM from here wants to talk to the VM here? That is not allowed by default. We have to do some additional configuration for that. Either we do direct peering between these two. That is one option, of course. If I do direct peering, every VM here can talk to every other VM here. But imagine there are multiple. There are, let us say, 10 spokes. How many peerings we are going to create? Too many that would become. So this has to peer with this, 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 this has to peer. I mean, all the combinations you'll have to do. So instead there is an alternative. Let me demonstrate this to you. So I'm going to use my East US VNet as hub, West US VNet as spoke, and I'm now going to create one more VNet, Central US VNet. And as I told you earlier, the easy way of creating is, I want a VM anyhow, so I'll create a virtual machine. I'll call it as demo central US VM. Let's say this is, we can either keep it as 0 or let's change it to 3. 1 and 2 I have used for the west. So 3 I am using here. RDP allow, I'm okay. That's it. Review and create. Now once we have this virtual network created and blah blah blah, I'll do peering, and that too with transit. So go to virtual network, east to west peering is already there. I want east to central. Go to peering. I should wait. East US to West US. I want this, and this will be West US to East US, and I should see here, sorry, central, not west, my bad, central, and central to east, central US VNet, and here I should use remote. So if your VNet has a gateway, this will be disabled. You can't even select this if your VNet has a gateway. And if your VNet doesn't have a gateway, this will be disabled. It has to use remote virtual network gateway. So this is transit. So now from my machine, I'm connected to, let's say this is my machine. Imagine this is my machine. From my machine, I'm connected to this VNet. And now I will be able to do RDP to a VM here. I'll be able to do an RDP here also. But from here, we should be able to do RDP to this, and that's not allowed by default. What is the solution? The solution is here we will have a virtual appliance, and we'll create a route table here for all the outbound traffic, which will say if the destination IP is in the range given to this, send the traffic to the virtual appliance, and from here to here communication is possible, and virtual appliance will forward the traffic from here to here. This is going to happen. The virtual appliance will be in this East US VNet, and we have created virtual appliance earlier. Virtual appliance is in East US VNet, which is the hub. So west will send to east, and then it will forward to central. Central will send to east and then forward to west. But how can that be possible? The only way that would be possible is via route table. So we now need to create two more route tables, one for central and the other for west. So go to route table. This is in east. Let's say central. User defined route. We have to wait till the next screen comes up. Yep, now go back to route table. In west. Now you have to remember what is the IP address of the virtual appliance, because that we are going to use as next hop. So go and verify the IP address of virtual appliance. It should be 1.0.0.4. No, sorry, 192. 192.168.4.4. This is virtual appliance IP. And now we have the route tables created. Central route table, I'll connect to all the subnets of central VNet. I have only one subnet though at this point of time, default subnet. West, I'll connect to West. So central is connected, west is connected, but there are no custom routes. So go and create a custom route in central for all outbound traffic to west. Destination type. So what is the range I have given for west? 10.1.0.0/16. Next hop is supposed to be a virtual appliance whose IP we got earlier. But for west we have two address spaces, 10.1 and 10.2 also. So 2 west 10.2, you might want to give like that. Destination 10.2.0.0/16. Next hop is virtual appliance, and this is the IP of the virtual appliance. So what are we doing? From central, any request to a IP in this range should go to virtual appliance, and virtual appliance will forward it. Reverse here. In routes of west to central, 10.3.0.0/16. This is central IP address space, and give here the virtual appliance. Finished, we are done. Now I can go to any one of these two VMs, and from there I can do RDP to this now. Guys, again I am explaining RDP is only for the sake of demo that VMs are able to connect. It need not be RDP software, it can be any other software also. It's the applications which have to talk to each other. It need not be RDP application, any application. If we are able to hit that IP, that means we will be able to hit any port on that particular IP, unless the ports are blocked in the NSG. But NSG will not block by default at least any communication between VNet. So now what shall I do? Now if I want to go to central or west, I can directly go from here. I have a central US VM and I give a public IP to that. Connect to that. This is central US VM. And what is the IP of West US? And that too private IP I am interested in. There is a West US private IP 10.1.0.4. I'm in central US machine. That's it. Once you get this particular window, it basically means that the connection is there. You can give password @123, the password, and we are in. So we went to the central US machine, and from central US we are able to connect to a virtual machine in East US. That means a virtual machine in one spoke is able to connect to a virtual machine in another spoke. This is the beauty of the hub and spoke, where we have implemented routing via virtual appliance. Now, something very important. When you're doing this particular example, you should have the virtual appliance already configured, which we have done in our route table demo. We have created the virtual appliance in a separate subnet. And of course, for that particular virtual appliance, we have also done port forwarding. So IP configuration and enable port forwarding. And not only that, we have to also ensure that at the operating system level, we have executed the command. Go to the same example where we did route table, this command. Compulsory, you should go into the virtual machine, execute this command and restart it. That's the virtual appliance. Compulsory, this example you should have done before practicing what I have demonstrated. The virtual appliance, IP forwarding and this part. Yes, also take care that if you go to a virtual network, I'm not very 100% confident about this, but yes, if you are going to a virtual network, ensure that go to the DNS server and change this to default rather than keeping custom, where I had 8.8.8.8 when I did in one of the demos, the configuration, change this to default. Not necessary, this is required step, but in case you are not able to connect, you can use this option. Now, how can we otherwise verify? See, all the examples I'm doing where I want to prove that the connection is being established is via RDP. Of course, RDP can be replaced with a more relevant application in one machine and talking to the other application in the other machine. Any application which the developers would have built. RDP is just a medium to demonstrate that it's all working, the connectivity is working. But the better way of proving the connectivity working is using Network Watcher. Use Network Watcher. And in Network Watcher, you can choose next hop or ideally IP flow verify. Let us do this first. So I go to a virtual machine in my West US and try to connect to a virtual machine in Central. Any random port you can take. And the virtual machine in Central has the IP address 10.3.0.4. Any random port number. Say verify. And you should see that VNet connectivity is going to allow them. If RDP is working, guarantee this will work. Sometimes it may happen that the rules are verified by this, everything is working, but in real time it is not able to connect. That possibility exists. You can do the other way also. Say in Central US, you are now talking to a machine in East, which is 1.4. So from 3.4, 1.4, verify the flow. Perfect. The connection is set up. You can likewise use next hop. I have a virtual machine in Central and I am trying to send a request to a virtual machine 10.1.0.4. What will be the next hop? it will not be VNet. It will have to go to the virtual appliance. 192.168.4.4 is the IP address of our virtual appliance. So it is supposed to show us the next hop as virtual appliance. Virtual appliance 192.168.4.4, and it's the other way also. So what is happening here? All the virtual machines in East US, which are part of the default subnet where the route table is configured, when they send a request to a virtual machine in West US, the request will be first sent to the virtual appliance, and from West US to Central, it will be sent to the virtual appliance, and virtual appliance being in the hub will be able to connect to the virtual machine in other spoke. But the question is, how good or bad is this configuration? Remember, this can become very expensive. Yeah, it is very good for demonstration, but what has happened here? My traffic is going from central to west, central to east and east to west, or from west to east and east to central. That means it's being exchanged in multiple data centers. There will be huge amount of latency instead of going from directly central to west, which could have happened in peering. If I did peering between central and west, direct traffic would have been exchanged. But now it is not going direct. It is going from central to east and then to west, and that can become a latency problem. And also egress cost of central is there, egress cost of east is there, double cost it might become. So though this is something very feasible solution, I would not advise it to be used in routine. This is very easy configuration. Tomorrow one more virtual network comes up and I want to be able to communicate to that virtual network from west. Just add one more route, let's say to something like South Central, and just give here the IP address range of South Central. Next hop, give it as virtual appliance, which is 192.168.4.4. Just by adding one more rule, we are able to route the traffic via virtual appliance to any other spoke, and all the virtual networks should be in the VNet peering of the hub. So from my machine also I can connect to hub. From my machine, if I connect to hub and then I can connect to any of these virtual machines. Of course, remember, every time you change the topology of your virtual network, make sure that you're also getting the latest VPN client software. You should go to virtual network, you should go to your gateway, actually virtual network gateway, and from the gateway you should get the latest VPN client software. That is also very important point to be taken care of. Point to site collection, configuration, and download this and reinstall and then connect. So from my machine I will be able to connect to east. From east I can now send the request to west, or I can send it to central. Any virtual machine, any of these networks I will be able to connect now after downloading this latest. Also, just look at the route table. We have created the route table. Originally it was front-end UDR, and in front-end UDR, if you look at effective routes, front-end subnet, the web1 VM, which is part of this particular subnet, when the outbound traffic is there, how does it all work? If it is 192.168.0.0, which is the same network, it remains in the virtual network. For internet, we are sending it to nowhere, which is actually wrong. This is default rule actually, so leave it. And then you see some extra rules got created here. We have 1.0, 2.0, these two are IP address range of west, and this is central. VNet global peering has been set up. As per VNet global peering, the traffic will be shifted from the east to west because of these two, and central because of these two. Global peering. Via peering, we can reach the virtual machines in that virtual network. So this is very important. Likewise, you can see the effective route for central. You will see that for west, it is going via virtual appliance. That is the user defined route which I have added. For the west, these two are west. I have added virtual appliance, the name of the route within the same virtual network. And 192 is east. Global VNet peering is happening. You are seeing here global VNet peering because our VNets are in different region. If they are in same region, you will see here simple VNet peering. VNet peering is very cheap because everything is within the same region. There is no egress cost. There is definitely no ingress cost. This advantage we are going to get over here. So this is how we set up hub and spoke model, where via hub we are able to create multiple spokes, and on these spokes we are able to set up connection by creating route tables. That's all in this particular session. Thank you.